Here are two Patton high velocity VNs. These are both 18-inch models. The one on the left being about somewhere in the range of 25 to 30 years older than the one on the right. We're going to do a blade swap on these today to see how the performance compares. And the reason why this is of interest is because the older Patton on the left has a shaded pole motor, while the newer one on the right has a PSC motor. The PSC motor is rated for 2.6 amps according to the tag on the back of the fan, and 2.6 amps according to the tag on a motor as well. Sometimes there's an inconsistency, but looks like in this case it's consistent. So that's 2.6 amps, and in this one with the shaded pole motor is rated for 5 amps, which is about twice the power. Now I think that we're going to find that the motors are about the same at top speed, because even though the shaded pole motor draws significantly more power and is physically larger, the PSC motor is significantly more efficient. And so the PSC motor should definitely have more startup torque than the shaded pole motor, but we're going to look more at the full operating speed as opposed to startup and things like that, because it doesn't really have much to do with the actual performance of the fan during operation. So let's do a baseline test of both of these units. We'll collect the power draw information and get an approximate idea of the performance. I won't be able to tell right now in live, but in the video that you're watching I will cut together a couple different clips of the fans running with the different blades and motors right next to each other for purposes of comparison. So we'll start with the newer one, PSC motor. And let's turn this thing on. We have right now 116.4 the volts. Start it up on low. This one does not have any warm-up time. It just gets going right away, as far as I recall. Whereas the shaded pole one seems to take a while to get up to full speed on low, especially. Maybe this one does too. I really don't remember. These are very, very powerful fans. So this is 1.57 amps, 168 watts with a power factor of 0.92, which is actually kind of low for a PSC. Okay, the medium, the switch is kind of busted on this thing. Medium is 1.88 amps, 203 watts, a power factor of 0.94, and high is 2.24 amps, 234 watts, power factor of 29. The motor is actually not very good in terms of power factor. It's exceptionally powerful. Very, very strong fan. Okay, so now we'll check the older one. Which is much heavier as well. Oh, the first speed is low, I guess. Okay, so this is on low now. And these blade sets move the ear very differently. I think this one provides a higher velocity, whereas this one provides a higher volume with a little less velocity. This is a pretty steady breeze. There's a little bit of gustiness to it, but it's very steady and it's very present. Whereas this one, it can get a little choppy. This is kind of more of a calm, high volume fan. It's relatively quiet. Power draw, 3.7 amps, 258 the watts with a power factor of 0.6. So we're already at significantly more power than the other fan drew, even a high. The medium, and the switch on this one is not broken. It does need a bit of a balance on it. Actually, quite a bit of balance on it. Okay, this is 3.52 amps, 267 watts with a power factor of 0.67, and the high, goes low, the high, they're actually about the same, I think. 3.86 amps, 290 watts with a power factor of 0.65. So this motor, being rated for 5 amps, is only pulling 3.8. Probably could have had a bigger blade set on it. These are both exceptionally powerful. Very, very powerful fans. Okay. So now that we have our baseline for both units, let's go ahead and swap the two blades. Hopefully I can get the blades off without too much trouble. And we'll move the blade to the opposing fan and see how it operates. The bearings on this one are much better despite being much older. Since it's older, it's typically just intrinsically better. Okay, so these both have Allen set screws. This one is easier, much easier to get to because it's in the front of the blade. Okay. Stop. We have to go get a... whatever. We have to go get a... oh no, this will work. This might not come off very easily. It doesn't seem to be expressing any interest in moving on the shaft at all. So I might need to go get a puller. Yep, I'm gonna have to get a puller for this. This is the second set of bearing pullers that I've had to purchase. The first set has still not reappeared, which is shocking. I suspect this one will give us the same trouble. Although this looks like it has less rust on it, so perhaps not. Yep, it's stuck. No problem. I need the bigger puller for this one. Both blades are off. Stick this blade on here, which is considerably heavier. So we'll have to see how what kind of a difference that makes. Watch this thing. Is this actually going to fit on here? It might not. Wow, just barely. It's going to be a very, very close fit. Whoops, that's a little too much. Okay, it does fit. Oh, almost. Let's see. I'm missing one of the hooks here. There we go. It does fit, but oh boy, is it close. Alright, now it's got this other blade on here. This one should fit with no problem. Throw some oil on these shafts. And put the correct blades back on the units. I like the way this guard attaches much better. The other one is like, this is not easy to use, but it's like more professional. The other one is just like kind of a joke. It's almost like some kind of an afterthought. This is always very tough to get the last one on here. Okay. Alright, so they're switched. And I actually kind of like the way both of these look a lot better. because this blade is in really good shape in terms of the paint, and it matches the rest of the fan. The guards are still shiny and everything. Looks really nice overall. And this one lets you see that really nice motor better. Well, let's go ahead and try these out. We'll start with the newer one. That's surprising, it got that right up to speed with no problem. 1.54 amps, 166 watts, power factor 0.92. I'm surprised that I'm not, because I know in my mind that the motor should in theory be pretty similar in power, but since this one's older, you know, the blade is heavier and the other motor's older, I tend to think the other motor is better. It moves the air totally differently. This throws the air out to the sides. It makes a really wide air path, which oddly I don't recall it doing that on the other, when it was on the other fan. And I don't see what difference the cage would make. The cages are very basic and don't really have any aerodynamics to them whatsoever. Okay, so that's 1.45. We'll give another reading. I think it went down. 1.44 amps, 158 watts, power factor 0.93. Alright, let's go to the medium. Well, this blade really needs to be balanced. 1.72 amps, 188 watts, with power factor of 0.94. High. Running about as fast as it did on the other ones, from what I could tell. Certainly not slow at all. Power draw is 2.23 amps, 235 watts, and a power factor of 0.89. So I think that it's turning out to be that the motors are going to be very similar. Yeah, this is about as strong as it was before. Alright, now let's try the old one. And we might find that the spin down time on that is significantly improved because of the weight of the blade. It's not quite as good as it was on the other motor, but it is improved compared to this lighter blade. Okay, so let's try this out now. Start up on low. This blade is in better balance, probably just because the blades are lighter. Power draw. Let's give it a minute to get up to speed. Now, I think it's running faster. 3.3, it is less load, because it's lighter. It must have had a change in volts because it just went down. 3.46 amps, which I think is a little less than it was. 3.32. 254 watts, the power factor 0.65. power factor 0.67, and the high, which is 3.91 amps, 297 watts, and a power factor of 0.65. And well, I actually think that this is stronger. And they're both very, very powerful, so it's hard to say for certain, but I feel like this might be a little bit faster than on the PSC motor. Run smoother because it's been better balance. You'll be able to tell as the video plays back from the other clip I just showed of the other fan in the original configuration. Very interesting. So I think, without having a side-by-side, I think that the PSC motor, I think the motors perform very similar, right? I think that the PSC motor handled a little better than I thought it would, the bigger blade, and this went a little bit faster like I thought it would. The airflow did kind of change. The old one kind of threw more air out towards the sides, whereas this newer blade was more of a concentrated stream of air. Which is, I did notice that before on the original configurations, but it seems to be more pronounced, which I don't quite understand because I don't expect that these guards would really funnel any air in any direction. I think it would just kind of let the blades do whatever they do. So we'll be able to tell better on the video. I'll type in the description if I feel any differently, but I think the motors are pretty similar in power. Maybe the older shaded pole motor has a very slight edge at top speed. The PSC motor definitely has more torque, but I think this is a good show of how the use of a PSC motor is a really simple and effective way to drastically increase efficiency without really increasing complexity or decreasing reliability.